Can you see my screen?
Yes, sir.
Let the recording start. Okay, so like we discussed in the last lecture, we are going to now talk about different kinds of technologies that are available in cloud, which will then be can be used or are used in creating solutions to the systems that we want to build on the cloud. First one is cloud storage. So we will talk about that. Now, storage is a general term, right? Storage is basically we want to store the data into the cloud. And that is one of the primary purposes of having cloud over there to store the data. And many times the data's quantity is very large. So capacity wise, features wise, different options, having different ways of being able to store the data, um, being able to back up the data, be making it available when required across the globe, planning for disaster management in case something happens, some catastrophic event happens. So all these things we are going to discuss in the overarching cloud storage topic. What we are going to do in way how we are going to do is basically there are a lot of technologies that are available. What I have done is I've split them into scenario-based categorization or partitions, if you would say. Um, for each kind of scenario, then we will talk about the scenario, then what are the technology options available in Azure for that, and what are the technology options available for in AWS. I mean, first could be AWS or second could be Azure, either ways. Or if there is some general purpose solution and then how that solution is implemented in Azure and AWS, we will discuss about that. So the first one is the basic need from if I am using cloud, it could be as simple as that I want to store some files on the cloud. Okay. Or maybe my application, for example, wants to run on the cloud and it is looking for some D column my backup directory, right? It is hard coded in the code. So if there is no D column, my application is not going to be able to save the files or search the files or find the files. So how can I cater to this kind of scenario where I need replica or simulated or virtual, you can say, not simulated, virtual file system on the cloud. So that is the scenario. We need to have disks and file system in the cloud for the VMs. So what is disks? Disks basically to store the information we need files, but files are kept on disks. Now earlier or hardware wise, they are an hardware asset, an hardware component, a disk, hard disk drive, or um, the um, the what you say electronic SDD drives without any mechanical components, right? So solid state drives. So those are the physical components, but we don't have direct access to the hardware in the cloud, right? At max, we have access to a machine which is a virtual. So it's not direct hardware access. So that means if I am looking for a disk, for example, I want to create a virtual hard disk for my VM so that I can attach it to some other VM or I can create virtual machines of the same operating system setting, right? Like we discussed that in virtual machines, once the virtual machine is created, we need to do all the setup. That means, let's say I have to install XYZ components and things like that. So if that is the case, then and the requirement is that I need to set some 50 odd VMs with the same configuration, then it becomes a problem for me because I have to either spend my time or run the scripts or things like that. One option could be you create one VM, create a virtual hard disk out of it, and then attach that hard disk to other VMs also to get the same software that you installed on one VM automatically available on the other VMs. That could be one, right? Or the data that the VM that you created first time, what information that has in terms of the data storage, you're copying it to some other. So you would need a hard disk, but it will be a virtual hard disk, right? Because we don't have direct access to the data. So how do we, or how the cloud providers cater to that scenario? What services do they provide us to cater to that scenario? Similarly, the file system, like I said, if our application wants to work with files, how do we go about it? So VMs would need disk drive for operating system, temporary data storage, like I said, right? Applications running on VMs may also want to access the files in a file system, just like they do while running on actual hardware machine. So why will this be required? It is important for cloud migration, like we discussed earlier. Migration is one of the key scenarios, and migration and hybrid execution or hybrid setup, where some of the information is on the hardware line on premises and something is on the cloud. So those kind of, that is where shared file stores. So you can create a share on the cloud, and it will be virtually accessible to anybody if they have the link, and it will look like a folder shared, right? Like I do share my lecture folder with you. So you see there, it is just like files and folders, right? But it is virtually that. So those kind of scenarios. Then you want to provide something for developers to collaborate and stuff like that. So all these scenarios require some sort of cloud provider service which will act as a disk or file system, as a virtual disk or file system. Okay, so AWS provides two kind of solutions for that. One is called Elastic File System, and second is called Elastic Blob Storage. So EFS and EBS. So EFS, as you can see, EFS is a kind of a file system which is could be shared across multiple VMs through file system modules. Okay, so you can have a concurrent read-write access because all the VMs are connected to virtually same file system. You can have concurrent read-write access and substantial input-output throughput, meaning the efficiency or the volume of the data that can come and go out of this EFS is very large. So therefore, it is useful where you want to have processing of very large data for analytics, for media processing, content management. Okay. Media processing, I worked on a project related to Sun TV, where they had this Azure Media Service for streaming purpose. Now that Azure Media Service is a PaaS solution where you don't have to worry about the file system, but the size of the file can become really large into GBs if it's a 4K content, for example. Okay, so media processing will require a lot of space because one file is in some GBs. So therefore, this EFS could be used to store such assets, right? And then could be this VM is processing it to convert it into some other formats or reduce its resolution to make it smaller and supply it to other subscriptions who are those customers who are not subscribing to 4K content, things like that, right? So for that, if that conversion software is running on this VM, it will need access to that 4K content, and then it will quickly want to put it in there. So all these things could be happening in parallel on different files. So this kind of scenario, if you want, you can use AWS EFS, and then for such things. Media processing could take a lot of data, and EFS is suitable for that. And content management, the same. Media processing or content management is basically similar thing. But if you want to have a kind of a traditional disk attached to the VM, like virtual hard disk in Windows terms, so then you should switch to or use elastic blob storage. Okay, so you create a blob storage and attach to the VM. So EC2 instances, the elastic cloud compute instances, which is VM in AWS world, um, is created, and you create a EBS volume, and then you attach that volume to that. So in one of the projects which my BTP students are doing, they were facing this issue that they created a VM, but for doing their development work, but the developer tools were, the requirement was such that it will create many GBs of installer files, okay, and their disk got filled up because the VM, so there was no EBS or any attached volume to the VM. Only whatever VM was providing in itself was there. And it is always a limited data. It is not a permanent data. And you should also be careful about this, that there is one OS disk which probably will have one few GBs of data disk, but there is something, I think 100 GB or something as a temporary disk available. So that temporary disk is should not be used to store permanent data, because it might change when you boot it next time. It should only be for temporary storage of the data. So that so in that work that I was just giving example of the BTP students, they did not have this managed disk attached to them. So they were facing the issues. The solution was to attach a physical disk, sorry, not physical, attach a separate service providing disk. The disk is a separate service. Attach that service to the VM, and then this becomes permanent or persistent. So the disk that comes within EC2 and the EBS, they are two different things. So that should be clear. And their lifetime is independent, right? So this is suitable as a disk for the VM, and it has got SSD and HDD options for the IO. So as you can see, you can opt for your disk or EBS being a HDD based or SSD based, solid state disk or hard disk drive. So as you can see, obviously hard disk drive is a mechanical unit, right? So if you are virtually creating a hard disk drive, the underlying disk which will be allocated to you will actually be a hard disk. So it might take a little longer to get the data and all. If you want quick access, then you can pick for SSD based EBS. Okay. So a regular disk, elastic block storage. More than that, if you want high performance data utilization, then elastic file system. Okay. So this is the EFS and EBS are the solutions provided by Amazon for the disks and file system scenario. Right? So then you can use all these, you can cater to these scenarios using these two technologies. Okay? So let us see what Azure provides. So in Azure, you call Azure Disks and Azure Files for that. Okay. So Azure Files will offer the file shares um, like regular file share on a server, physical server, the path will be shared. So similarly, you can share such file, create the file share on the cloud and share the path with the people who can use, depending on read or write access, that share. And using the SMB protocol. So it is the ideal replacement for file shares on premises. So that's what basically it is, right? It is basically catering to the scenario where we used to have these file shares, for example, lecture folder, right? If we decide to remove all the hardware from DICT and move it to the cloud, and if we move it to Azure, we will be using Azure Files for creating the same lecture folder, right? Or some other or the uh, this elastic block storage, I guess, for the regular shares in AWS. Then they can be mounted concurrently by cloud or on-premises deployments for Windows, Linux, and macOS. So these shares can be mounted when you are deploying, when you are creating virtual machines, and therefore can be used as a disk for the file system or the file system for that VM or a file application. So you can share a file system across multiple machines, applications, and instances. Then Azure Files can be cached on Windows Server with Azure File Sync for fast access near where the data is being used. So they have this Azure File Sync, which is kind of a caching mechanism of Azure Files. And caching always helps, like I told you. So they have this file sync caching system also available, which can you can cache the Azure file data for quick access. Then we have got Azure Disks. So Azure Disk is like OS disk, like I said, right? When a VM is created, an OS disk is assigned to the VM, and one temporary disk is assigned to the VM. There is no data disk as such. Okay. So for if you want to keep a data disk, or if you have a data in the VM which you want to save, other than on the OS disk, because OS disk will have limited capacity. But if you have like 500 GBs of data or 2 TB of data, so you will need to create a separate data disk on the VM and attach to the VM, and then save that data VM wants to do on that disk. Earlier, there was some simple regular disk creation, but then they made something called managed disks. Managed disk is basically you can create and manage its lifetime and stuff. So they then name the regular disk as unmanaged disk. So now we should always use managed disks, meaning attach a managed disk instance with a VM. So I think if we go to portal and mm, create a virtual machine. So you can see here disks, right? So you can opt for what is your OS disk type, and there should be some other use managed disks. See, Azure VMs have one operating system disk and a temporary disk for the short-term storage. You can attach additional data disks, right? So we want to attach additional data disks. So you have got this encryption facility as well. Okay, here it is. So if you want to attach another disk, that is how you do it. So you create a disk, and then it will attach a disk. So if you attach a disk, you can detach it also, right? So if you have a disk already created, that will be a managed disk. You can attach that disk, existing disk as well, to the new VM, right? So this is how you can attach additional or data disks with the virtual machines, and but detach them, and they are basically independent in their lifetime, like it was for the case of EBS and EC2 instances. Okay, so managers handle the storage account creation management in the background and ensure that you do not have to worry about scalability limits. So these are the advantages of managed disk versus what was there unmanaged. So they can scale automatically, and you can specify the disk size and performance, and then it will manage everything else for you. So you just need to specify how much size I want and how much performance throughput I want, and Azure will provide it for you. Okay, so that is the solution for uh, disks and file systems. If you were to use your cloud as a disk and file system thing, how you can do it. Okay, so that is the scenario catered to by Azure and AWS for disks and file system. As one good thing is, this cloud computing is very new, right? Cloud system. Earlier, for example, old languages like C or even C++ or even some to some extent Java, there were features introduced just by developers for developers. There was no business or not much required business involved there. So they become like a old or traditional or not to be understood by business people kind of things. Okay. Fortunately, in cloud technology, if there is a service available in the cloud, there is a business reason behind it. It is not for developers. It is not for engineers like us. Cloud is there for business. So if there is some X service available in the cloud, there must be a scenario, a business reason, a reason for it to exist. It cannot be like earlier that some developer thought, oh, this is a cool feature to be there in the language or in this technology. No, that is not the case. Every cloud service is well thought out, even though it might be a technical solution or for creating some technical thing, right, like IoT or something. But it will be a well thought out business decision to introduce such service or feature in the cloud. So if you see some service name, or if you come across any service running in the cloud, I would say you should know why it is there. Go after to find out what was the business reason for that service to exist. Okay, so what it would be mean like that? Suppose you did not know about. If we are coming from the top down, right? We are discussing about the scenario first, and then seeing what these solutions, what the AWS and Azure provide us for that. But what I'm talking about is it may not be always possible like that. Let's say some service I am not covering in this scenario and solution based model. So suppose Azure Disks was such a service, and you come across about that. So what you need to, your endeavor should be, okay, Azure Disk, I have not heard about this. So you read about it, what it does and all, and then slowly from different reading from literature, from YouTube or from reading other articles, you come back to this. Okay, the disk Azure has is catering to these scenarios. Okay, these are the business scenarios, right? I want to have an operating system on the disk. I need on the VMs. I need a disk for that, right? I want to have data storage in the virtual machine because I am migrating my machine from my office to cloud. I need a data storage. Operating system storage and temporary storage may not be sufficient. So I will use the data storage as a disk service. That is why Azure Disk is there. That is why EBS is there, Elastic Blob Storage, right? So you need to keep that in mind that what is the business reason or why that particular service is introduced by somebody, where it is required. If you do that right, it will help you step out of just the technical aspects of our program or our course. It will help you to understand how the business gets connected to the technology, and that helps in your career when you grow further. It helps clarifying things that seems to be at odd when you do coding, and sometimes you say why I am doing this even. Those kind of questions will not, those kind of confusions will not be there anymore if you have this attitude of, at least for the cloud computing, go for finding out why the service is there, what is the business reason behind it. Okay, what are the scenarios why they are there. Okay, so we have covered that. Now for the first scenario, what are the ways to create disks or simulate, sorry, not simulate, simulation is different. Virtually enable disks and file systems in the cloud, right? So we have discussed these things. Any doubts, any questions for that? Anyone so far? Anyone? Okay. So we move to the next part, next scenario. Now we want to serve static web content and media. Okay, what is this scenario about? Now we have the websites where we open the website and they serve us the content we see in the browser, right? The content is of two types. One is a static content and one is a dynamic content. Dynamic content are information that keep changing. For example, news, weather forecasts, some game scores, right? Stocks, and many such things. It could be even live streaming also, right? That is one part, but many of the content will be static. Okay, so if some news has been published, that becomes a static content. So you go to that URL, you will always be served the same content again and over and over and over again, right? Pictures, they are static content. Once it is uploaded and available at a URL, it will be available at a URL forever, right? For all practical purposes. So when you are opening a website, it might be serving a mixed content to you. Some portion of it will be static content or fixed content, and some might be dynamic content, right? So static content could be text, which is smaller in size relatively, but it could also be a media. Some YouTube video is uploaded, it becomes a static content. You always get to that URL, you see the same video playing over and over again. But the content itself, the video could be large in the size, right? The stream size could be large. So the scenario is that if I have only so like YouTube, right? It has now I think live streaming feature also. But if you take that out, YouTube is basically serving static content only, right? You don't uh, upload while you are live, upload the video unless you're doing live stream, right? You first create the video, upload the files, and then YouTube processes it and then publishes it on the YouTube, right? Then only other people can use it, and everyone else will see the same content. That means the video that we have uploaded is a static content. So YouTube is 99% static content, I would say. So that means serving the static content is a very compelling use case or business scenario, right? So how this is possible? What services the cloud service providers are providing to make it possible to serve static web content and the media, right? So that is the second scenario. How can cloud help us meet this scenario? Because this is a real business scenario to be able to serve static web content and media. It could be other way around. I am from Azure. I want to convince my customer to move their website from their hardware servers to cloud. They will say that I have a lot of media content that I serve. How will I do it on the cloud? Right? So as an Azure person, salesperson, I should know I am coming into this category, serving the static web content and media. I need to know what services are available, what is their quality, what are their cost, what are their throughput, how the migration experience will be. I need to have all those answers in my belt, under my belt, so that I can satisfy the potential customer and convince him or her that your website is better at in Azure cloud than on your own servers. By factual analysis, cost benefit analysis, all those things I will need to know, right? So it is an important business scenario. So static web content typically include HTML pages and other resources like images, videos, and documents. The documents could be scripts like the JavaScripts or jQuery and things like that, PDF downloads, etc. So all these are static web contents. Although the web servers are well tuned to optimize requests through efficient dynamic page code execution and output caching, they still have to handle requests to download static content. Okay. The question is that I have a web server already running. My website is running. So why would I need a separate scenario for static web content? Because my web server is able to serve this content, right? My web server is running and it is getting requests for the pages and it is serving those. The problem is that it is trying to execute some code and then fetching the data from the server and then sending it to the content to the what do you say browser, right? At the end of the day, it is just a static content. All that was required was to somebody to just grab the file from the backend disk or database and send it to the front end, right? So the intermediate web server is running, so it is consuming CPU resources, right? It is executing some code to serve the content that is also executing CPU. So CPU execution should be minimal actually because there is nothing to process really. All we have to send is a file, an HTML file or bunch of an HTML file with a bunch of JavaScript files and CSS files. That's all we want to serve, right? Or the video that can be downloaded, something like that. So the CPU that is getting used by my regular web server is a waste of resource mostly if it was all it was doing was serving a static content, right? So that is not an optimal use of web server running on the cloud. Why? Because we are paying for it, right? We are paying for all the resources getting used. So if all my web server is doing is serving the static content, I should explore at other options which can reduce my cost because I don't have to pay for dynamically running website or web server if all I have to do is serve static content. So it means our goal is to minimize the need for a compute instance to serve the static web content and media. Okay. So I hope you are clear about this. Any doubts? Why web server is already running or how from where web server came into our discussion? Any doubts over there? Okay. So the goal is to minimize the need for compute instances. So what is the solution? So this is a generic solution. Okay. So I need to uh, serve the content directly to the user bypassing the CPU because that's my goal, right? Minimize the CPU. And CPU does not help because all it needs to do is just pick up the URL and then convert it into something and then pass it back to the page. So why not pass it directly from wherever it is stored, right? So what I do is, so this is the client, okay. Now initially when client logs into abc.com, so this is the application, this is the web server, right? It is it will serve the initial set of pages that the browser will see. Right now the myapplication.com website is open. Now all the links in that website in that page are static web content, right? So when the client clicks on that, it simply brings that from the storage because it is directly linked to a resource over there. So some it could be these kind of files, it could be images, right? So all these are directly served from the container my resources. The container, it is a storage container. It is not a CPU or it is not a web server. It is a cloud service where there is a container or a folder called My Resources, and inside of that you have got these different resources or content, and the URL will directly get that content to you bypassing the web server, right? So this is the general solution that we need to store on the web in a particular format or hierarchy the static content and then embed the URLs of those static contents in the pages, and when the client clicks on that it will fetch that thing. It could be a new page or it could be something else, but we also need to take care of the security part of it and gets to read and write, and then how do we deploy this on the cloud, how does it work. But general idea is this, that we need to have something called URL based storage service, because if the storage service can directly give me my content, right, based on the URL itself, then my application doesn't need to create the query to get that information out, right? For example, in the SQL databases, you don't have a URL, right? You don't have a URL to a particular row of the table. You have to construct a query. So in that case, for example, if client page has that information, client clicks on that URL, but that information is not in the this kind of setup. It is in the database connected somewhere here. Then when the client clicks it, application gets that URL because on the client side it is still a URL. It comes to the application. Application now converts that or transforms that URL into a query, the SQL query. That is CPU utilization or consumption. That SQL query is sent to the database server. That is again a CPU consumption. SQL query gets executed, the result is brought back to the application. The application converts that back into JSON format. That is again a CPU utilization. And that JSON format is then sent to the client, right? That is again a CPU utilization. So that is how it would be done in a typical non-cloud in a scheme if this URL-based storage device service is not available. Versus if URL-based storage service is available, the application can simply send that request to the container, or it can actually directly go to the container. The URL itself will know the path to the container. Okay, but there is a aspect of security that we need to take care of while exposing such things. Okay, so let's see what are the solutions, how this generic solution is implemented in Azure. Okay, so in AWS solution, we have got Amazon S3 simple storage service as the URL based storage service from Amazon. Okay, so when you upload something on an S3 bucket, it is called buckets. When you upload into S3 bucket, the S3 bucket service will return back a URL for that bucket, a unique URL for that bucket, and whosoever has that URL can get access to that bucket. Okay, so that's what. So we can use that URL in our pages and then give the access to the user. Okay. So important to know that each object has its public or access URL. So it is not, we don't need to query the object. Each object has its URL, so you can simply use that URL to get to the object. And you can store from 1 byte all the way till 5 terabytes of data in the S3 storage service. Okay, and apparently it is highly scalable, so it allows concurrent read and write access to the data by many separate clients and application threads. So it is highly scalable. So once you store the information in S3, hundreds and hundreds of clients could be reading that information at the same time. Doesn't matter. Okay, so it is very highly scalable. Then in the same region using S3 with EC2 instance, it is designed to be fast. Meaning, if you want to combine EC2 and S3 bucket for a combined solution, meaning somewhere where you need VM and S3 bucket to coordinate with each other, meaning EC2 reading from S3 and stuff, we should try to put them in the same region. And then it will be, they are designed to be fast in that way. But it cannot be used in place of the file system because there is no hierarchy. File system has a hierarchical thing, right? You have folder and then folder and folder, files and stuff. You can't use that in S3. It's just simply flat URL based scheme. Okay. Second, you cannot query the data. You cannot say, give me all the S3 buckets which has objects starting with their name as XYZ. Doesn't help. Right? So you cannot query the data. You cannot replace it as a file. It is not suitable for rapidly changing data. As we anyways are discussing, we are talking about static content, right? Static means does not change, remains same. So obviously it is optimized for that kind of data, not for the data that is changing. So if you are having fast read and write operations, S3 is not the right storage technology for you. It will work, but you are not using the most optimal storage for service for that. So these things are very important to understand. Which technology has got what pros and cons, or what are their designated or targeted scenarios, right? That's why we are covering in this fashion, scenario versus solution. Because one size does not fit all, right? So they will provide different options, different technologies, and we will be we should be knowing those things, because if we know, then only we can optimize or we can decide whether X service is better for this or Y service is better. And if X is better, then X may, which version is better or which way we need to configure it. So that is the knowledge that we need to gain. In the cloud computing, especially the approach that we are taking, right? We are studying cloud computing from as a user of cloud technology, as the engineer or software engineer who will use the cloud for developing solutions. We are not building the cloud, right? So in this perspective, it is all about knowing. It is not about discovering, or it's not about inventing new things which might be required when you are building cloud themselves. But while using it, all we are doing is already existing services we are using. So how will you have edge among all of people who know cloud? The edge will be your knowledge. Not I mean, not the invention kind of knowledge, like deep knowledge of data structures. That's not going to help you in the cloud, right? You need to be aware of the services that are available in the cloud. What are they used for? What they should not be used for? What is their cost involved, right? And how different services can be fitted together. That I really talk to you. If you have an enough deep knowledge about how these things, which are the services and what they should be used for, automatically you will create knowledge pools. You have become your storage knowledge pool, your database knowledge pool, your compute knowledge pool, security knowledge pool, right? All these things, when they get created, automatically your brain will be able to pick up things from all these things and create a beautiful solution for the business problem that your company is solving. But the prerequisite for that is deeper knowledge. And in cloud computing, especially, it is all about knowing. Do you know about this? Do you know about that service? Do you know about that? This is the new feature that has come. All those things you should be aware of. Very, very attentively, you should increase your knowledge in this. Some of the content could be now getting obsolete here in the slides that you're seeing. You should put effort to verify that what I am saying is correct. Also, see if something else has come on top of it. See if there is a service that is now very useful, but I am not covering in that. You should be inquisitive, right? Don't depend on just these slides that you know every sir knows everything about code and I will just read what sir tells. It is much beyond that. So you need to be creating this knowledge of what are the services available, why, what is the business reason behind that, where they should be used, and where they should not be used, and the cost involved. These 4 and 5 aspects for each service. It could be a brute force mechanism also. You can prepare a chart, large chart of all the services in Azure, right? And then have these columns. Business reason, where scenarios which it should be used, where it should not be used, maybe how to use it, and then the cost involved. Put it in your study room, and then you can just keep filling it up as you come across new services, um, new information through the lectures. That is the way you will increase the knowledge, and then you have to, okay, you know about it, and then you understand, okay, I have got the knowledge, but how will you showcase it to the user or to the prospective companies, right? One is somebody takes your interview. Second is you get yourself certified. So once you attain good knowledge, attempt to clear the certificates that these Azure people uh, offer. And once you have the certificate, people trust these certificates. They are quite respected, and you should basically, you know, try to do that. So coming back to this, so this thought process came to my mind when I saw this, that where you can't use this, so you should be very careful about it. Okay, and then it is not very useful for rapidly changing data. Better solutions available for archiving data. This is also important. Now we have got this 5 terabytes of space, right? Now the scenario is, mm, let's say your company is generating daily reports of some usage, right? And then after every weekly meeting, those reports are almost never sought again unless there is some inquiry or query or some follow-up needs to be done. So let's assume that after 1 month, the previous month's report almost are never accessed, right? So, but the volume of the report is much larger. So your company is asking you, how can you create, what solution you will create for it. So you have read about S3, so you'll say, okay, we'll use an S3 bucket for that because it has got, it meets the criteria, right? It meets the criteria that uh, large storage capacity is there. It is a static content. The report is a static content, and it is the S3 bucket is supposed to store static content, right? So that is also checked. Large size check. Not changing, rapidly changing data check. So all these things are checked. Therefore, S3 is the suitable scenario, suitable service for that. Not true. Because S3 bucket, what we ignored in all this check was the capability of S3 bucket. It is meant for fast read access, right? It is meant for fast read access. So large database, large data size check, static content check, right? Fast access, not required in our scenario, reporting scenario. So that means that is where your bell should ring. That the main purpose of S3 being S3 is not required in this reporting preserving scenario. I want to preserve or store the reports, PDF files, let's say, or Excel files into S3 bucket. It's not required because I will hardly access it. That means there could be a solution that is exclusively for this kind of storage, that is called archiving. Archiving means you put it into cold storage and hardly access it any time later unless specifically asked for, right? That scenario is different than readily available fast read access. Completely different, right? Even though some of the characteristics match. So if you are using S3 bucket as an archiving solution, that is not the right usage of S3 bucket, even though most of the checks it matches. There are separate solutions for archiving. Okay, and if you don't know about that, then you will need to find out. But like this, if 3 parameters are matching, don't ignore the last one or don't ignore the others. List all the parameters or in what scenarios a particular service is used, and does that scenario is what you are solving. Reporting, storing the reports permanently is not the scenario that S3 is meant for. So you need to be cognizant and alert on these things. And if you are not, you will guide your company that, okay, we will use S3 buckets, right? Next year, your junior will come who would be more attentive and join you in the company, And then he or she will say, oh, we are using S3 bucket for reporting, report storage. Why? We have this AWS Glacier service for archiving solution. He will tell in the company meeting or team meeting that this is the wrong usage of S3 bucket. This solution is there for archiving. We should use to do that. And then the management will calculate how much money they have lost because they were using S3 bucket for storage so far. And then they will trace it down who recommended this. And then they will simply replace that person with a new joining. That is how business runs in companies. Okay, that means you'll get fired, right? So it happens actually. So be aware of it. It's not a fluke. It's not a joke. It can really be such scenarios. Though this could be a far-fetched for firing, but it could happen depending upon how much cost the company has incurred, right? So it pays to be knowledgeable. Okay, so don't take it lightly. What I'm saying, if you adhere to this, trust me, I have seen the world. 20 years in IT industry and still going on. So these things matter. So build your knowledge deep. Solutions will automatically come. Building the deeper knowledge is the problem. That is where people miss out. Okay. So there are better solutions available for archiving the data. Also, obviously, it is not suitable for dynamic website hosting. It is not meant for dynamic. Dynamic means read and write, right? But S3 bucket is only read only. So optimized for read only. So obviously for dynamic website hosting, it is not suitable. So that is the amazing solution S3 for static web content. The basic requirement is what is the service a cloud service provides, which can give me access to the stored data with just a URL, and that URL is always constant. Okay, URL based storage service, that is the solution. So Amazon S3 provides URL based storage service. Okay, so any doubts, any questions? All right, there's nothing. So now let's discuss what is the solution provided by Azure. So Azure provides something called Blob Storage. Okay, so it is similar to S3, but it has got its own little bit details. Okay, little more detailed, or what you say. We have got more options in Blob Storage. So again, Blob Storage is optimized for storing massive amounts of unstructured data. Okay, unstructured data, not like hierarchical data, which has some fast indexing available, things like that. So text and binary data. Again, it is a URL based each blob or object. So we will, in Azure world, they are called blobs. Each blob has got a public URL. Okay. You need to have a separate storage account for that. So once you open Azure account is not enough for you to start the storage service. You need to create a storage account also. So once you create a storage account, then you can create containers, right? So those containers can have further containers, and then the containers can have blobs. So it's like hierarchical solution, but the data is always at the leaf. Okay, and you have direct access to the data. Containers could be part of the URL, but the URL will not get only to the container. It will, you can fetch it directly the data, no matter where deeper in the container paths it is. So there are three types of blobs actually. S3 bucket was only single type, but Azure has got blob storage, which are of three types: block storage or block blobs, append blobs, and page blobs. Okay. So what are the block blobs? So block blobs store text and binary data up to 4.7 terabytes. So they are made up of blocks of data that can be managed individually. So up to 4.7 terabytes of data you can use using block blobs. Okay. Uh, you can, so this is the most close to what S3 bucket is meant for. You can use it to store text, binary data, any archiving, any large files, media files, things like that, right? So primary type of blob that will mostly be used will be a blob, okay? And they provide access to blocks which can be managed individually also, right? And each block will have a URL, right? So it could be it's like 1 byte to 4.7 TB, right? So if you store a block which is of 10 MB size, that 10 MB size will have a URL. It's basically an object, right? So blobs is the equivalent of S3 bucket. But what is append blob? Now one of the scenarios, so they are made of the blocks like blobs, but they are optimized for appending operations, right? So why they have come up with this optimized for append blocks? Why the blob storage is there? So there must be like a business reason, right? So when application is running, whether on the cloud or on premises, it's a common scenario, or it's a common practice that it adds logs to somewhere, so that if, let's say, some problem happens, you can check the logs and try to figure out what happened. Okay, because the applications are running on your customer sites, right? You cannot debug there. You can debug only in your development environment. So the practice is that on the customer side, they will keep adding data to the logs. And if the application crashes or customer reports some issue, you will ask them to hand over the logs to you, or there will be an automatic getting of logs, things like that. Those kind of services will be there. So logging is one of the most common practices that are followed by applications when deployed on the customer sites. And same is true for cloud applications also. In fact, there are um, there is something called application insight. So application insights is a kind of a automatic logging service, um, when available for the PaaS solution. So if you deploy some application and enable application service insights service for that application, it will automatically tell you what happened when the application is running, and it shows all the analysis and stuff. So it's a separate service in Azure, but in any ways, you could, for your own purpose, because application insight cannot go into the details of the code. It does not know about your code, right? But it can get the overall working, how the application is doing, which method is taking longer time, getting called most often, things like those things can be done, right? But inside of those methods, how the code is running, what function you are calling, and things like that, which object you are created, those things might be suitable only when you write the logs to. And obviously, application insights provides hooks where you can write it to application insights. So it's a logging service, right? But if you don't want to use application inside, or you are having some other requirement, you can use append blobs for that. Now, logging is such that it is a time series based thing, right? You log once and then you log next and then you log next. It's always sequential and on time, right? So it might be more effective or cheaper or efficient in either ways, some advantage, if you have a blob or if you have a blob service which is optimized for append only operations, right? That is the need or that is the motivation for Azure to provide this separate service or separate type of blob which is only called append blobs, right? Because they are ideal for scenarios such as logging from virtual machines, right? So append blobs are meant primarily for logging purposes. Okay. Again, if you end up using blobs for logging, that's not the right use of the service. Maybe append blobs are cheaper because blobs can may have to have random access to anywhere, so they might be costly. Append blobs might be simpler or cheaper. You should know that. And if you want to use the blobs, so append a blob, what they will do, they will create a container on the cloud. They will create a container and the data will go inside that container. But if it is append a blob, or when you create the container, you tell that this is for appending, then it might cost a little less, I guess. Okay. Then the third type of the blob is page blobs. So what is page blob? It is basically for random access files up to 8 TB size. So this is meant primarily for the VHT files to that back up the VMs. So if you create a VHT file, okay, it's a virtual hard disk file. It contains all the data of the operating disk. So it could be quite large, right? So if you want to store that somewhere, page blobs is what you can do. You can upload the VHD, get some URL, and then you can attach it directly, I guess, to the VMs if I'm not wrong. Okay, so Azure solution of URL-based storage service is blobs. There are three kinds of blobs, and blobs are the most common used blobs. But for logging purpose, we could use append blobs if you were to create VHD files or the hard disk files. You can use page blobs because they are optimized for random access files, right? You can mount that VHD on a VM and then operating system could randomly access from that blob fast and bring your VM up and running. Okay, and the constraints are similar to what we have got in S3. It's a URL based storage service, so it does not support queries. It does not support search because there is no indexing, right? Search needs indexing, and it does not support file based access. Such constraints are also there on the Azure Blob Storage also. So as you can see, the solution provided by either AWS or Azure are on similar lines. Just their nomenclature is different a little bit. Their some services are in more details than the other service, right? Size differences could be there, but ultimately the fundamental ideas are same. They solve the similar problems, right? So um, that is why in the beginning, I said that you could either pick Azure or AWS or anything, because ultimately they will solve the same problem with some similar kind of approach. Okay. All right. So I think we'll stop here and then cover remaining scenarios in the next lecture. Let me know if you have any questions, queries. Otherwise, we can end the call.
Sir, 8 TB is the limit of storage in Blob, right?
Yes, 8 TB is the limit for page blocks.
So if there is a file that is more than 8 TB, so how it will be stored?
Good question. I think there is no direct way to store it. You'll have to use some utility to split the file first and then upload it in page blog. Okay, or having managed disk which is of higher space, higher TB, and store it in that. This is page blob. Remember, this is not a disk storage. It is a storage location or a container on the cloud, and you are adding data to that.
Okay, sir.
Sir, so we can't contain media files in this
Where in the page blobs,
blob storage.
yes, you can. Media file up to 4.7 terabytes. It's not GB, it's
Okay,
TB.
okay.
It's
Hello,
more.
sir.
Sir,
Hello,
so you,
sir. I mailed you. Can you please check the mail?
Sorry?
I have mailed you. Can you please check the email?
Mailed what? Can you tell me
Uh,
what it?
sir. So in my registration course, I have not tick tick marked the cloud computing. So it was e-campus issue. So I have mailed register,
Uh-huh.
and they replied 3 days ago that I they could added this course in my course list. So can you please share me the classroom link and assignment and all of that?
No, are you not part of this group
Uh,
of cloud computing class people?
no, sir. No, sir.
What is your
2 days
what is
ago,
your
they have added this course.
what is your ID? 201
19 010 88 010
82.
88. And
So you
can
could
you?
have joined just with the code, right? Somebody can tell you this is the
Yes,
class code.
yes, sir. But मेरी वो लैब असाइनमेंट और सब बाकी है ना, तो इसलिए मैं बोल रहा था कि
Okay,
फिर
this
से वो.
is you have got the invite, so you should be able to see now.
हाँ, तो मैं अब कर सकता हूँ वो फर्स्ट लैब और सब.
Assignments?
हाँ.
Yeah, you should do it because see, we are going to take a while we come back with new assignments because we'll cover some material and then we'll do. So in the meanwhile, you try out these assignments.
हाँ, पर डेडलाइन के बाद अब करूँगा तो कोई.
कोई बात नहीं यार, it is more about learning than deadline. So don't worry about deadline.
ओके
Just
सर.
finish it.
थैंक यू सर.
Okay. Anything else, anyone? All right. Take care then.